We are going to look today at second derivatives. So we're not really going to use them, we're just going to find them. But let me just tell you what the point of them is. So if I have f of x, that is just the function, right? If I have the derivative of, okay, this is what? The gradient of the function, okay? So the derivative gives you the equation of the gradient of the function. The second derivative, boys down the back, do you remember what the second derivative means? Yeah, but what is it? It is something to do with stationary points. The nature of the stationary point. So this, yep, we can certainly write it like that. What's another word for a stationary point? Yeah, sure, vertex. What else? Turning point. So this tells us about the nature of the stationary point, kind of whether it's like this or like this, right? So it gives us information about the curvature, whether it's convex or concave. So essentially what you're saying is that if it's greater than 0, so if, let me write it like this. If the function, actually, I'm going to write it differently. Give me the eraser. All right. So if the second derivative is greater than 0, or the second derivative is less than 0, we can tell what the shape is. This is a smiley face. This is a frowny face. Okay. We're not going to need to use that at the moment. We're not going to have to then go to the nature of derivatives. I just want you to know what the point of this is, so later you will be able to use it when you have to. Essentially, we are finding the function, we are finding the equation of the gradient of the function with the derivative, which helps us to find gradients at certain points. And the second derivative, which we're going to do today, tells us about the nature of those stationary points in the graph. Because if the second derivative is greater than 0, it's a smiley face. If the second derivative is less than 0, it's a frowny face. Now, that's pretty useful when you have things that look like this, right? You've got heaps of different turning points, lots of things going on, and you might need to isolate various sections, right? You might need to figure out what's going on at different points of the graph. Now, I did put something on Google Classroom just as a reminder about what it means. So if you're someone that, again, likes to understand why we're doing what we're doing, I've just put a slight summary on there of this. We're not going to actually do anything with stationary points. We're just finding second derivatives today. So let's have a go at doing it. It won't be difficult because it's nothing new. It's just doing derivatives of stuff. I didn't understand any of that. I still can't hear you. You can do that later. Okay, so what I'm going to do is I'm going to give you a function. F of x is 3x squared minus 2 all squared. And I would like to find the derivative of this function. So what should I do first? Sorry? Yeah, okay, so let's expand this out. So let's do it a shortcut way. If I'm going to expand these brackets, what do I get? 9x to the power of 4 minus 12x squared plus 4. Good. Okay. So that's our function. Let's derive it. What do we get?
36x cubed minus 4.
Okay, great. That is the equation of the gradient. And if we want the second derivative, what do we get? Okay, well done. All right. So another way of writing this. So when we write the derivative, we do dy dx. When we write the second derivative, we write d squared y over dx squared. Okay, that is the notation for a second derivative, either this version or this version. Okay, so this is the first derivative, this is the second derivative. So if you see both of these notations, they mean the same thing. All right, let's do an example where we have more complicated things going on. What if we had fractions and negative powers? Everyone's favorite. Okay, if we have f of x is 6x cubed minus 10x plus 2 over x, what do you think? Okay, then what I'm going to do is I'm going to say find that. What does this mean, this notation?
Sure, of the stationary point, and then put -1 in as x.
Okay, so I'm going to find the second derivative, and then when I've done that, I'm going to make x equal -1 and find my value, okay? So what should I do first before I try and derive this? Fix the 2 over x. How would I fix it? No. Good. So I'm just going to rewrite it as a negative power, right? Now I can derive it. So if I'm looking for my first derivative, what do I have? 18x squared minus 10 minus 2x -2. Good. What about my second derivative? -3, right? So this disappears. These two negatives are going to cancel each other out. So I get positive and I have a -3 power. Now I have to find where this function is -1. So I'm going to say -36. Well, actually, yeah, let's do it like that. Okay, so then let's just write it out properly. So this is -36. And what's this bit? -4, because this is going to be -1 cubed. Is that what we're doing here? Let's have a think about what this bit means. This means 4 over x cubed, right? If x is -1, -1 cubed is -1. 4 divided by -1 is -4. So this works. See what we're doing? 4 over -1, which is -4. So that becomes this. So it is -40. Well done. Okay. All right. If x is greater than 0, no, if the function is greater than 0, then I'm going to make sure I say it the right way round. If the function of x is greater than 0, it's a minimum because it's a smiley face graph, right? Say it again.
There's no turning point on this. On that, next photo.
Mm.
Can't give you the nature of the turning point.
No, sorry. This is just about what it equals, right? This function equals 40. So this is not a turning point. This is a point. This is not a turning point.
Yeah.
Sorry. So, okay, let me make that clear again. Let me get rid of this. I'm going to stop this.